is, computer definition is. So let's begin. So as a basic computer organization, if you see, in which the input unit, which is important for the receiving data to the computer, output unit is there in a computer organization in which the results are going to be displayed. There is a memory unit which are required to store or to hold some instructions, and the most important is CPU, that is central processing unit, in which we have two subcomponents. One is ALU. ALU means arithmetic and logical unit, and one more is CU, that is control unit. So of course we are going to see one by one every or what that particular unit is going to do. So as I have mentioned here the list, the input unit, output unit, memory unit, and CPU. These are the four main components of a computer organization, without which a computer cannot perform anything, or it is like you can say it is in a meaningless. Okay, so let's see what are these again. So as you can see one basic structure of a computer here, how a computer nowadays, see earlier there was a monitor, there was a CPU system box different, there was a power supply which is different, but nowadays you are getting all in one. All in one means in which monitor, wherever whatever in whichever device you see the monitor or you see the screen, background, in the background it is behaving as in a system box also, that is CPU. It is giving us the option to connect the input device, plus it is itself is an output device as well. So all in one computer or all in one devices means everything in embedded in just one particular device. There is no different system box in, or there is no different power supply unit using which you can run the computer. Earlier it is used to happen, monitor एक screen, keyboard एक अलग से, mouse एक अलग, power supply अलग, उसका CPU का system box अलग. So it was like that, but now it is not. It is all everything at in one place. Okay, so in this structure as you can see there is a exactly CPU is belonging or connected, or you can say inserted on the motherboard. So input unit is responsible to accept the input from the user. So once the user is going to input, then it is going to the CPU. CPU in which we have three components here. That is memory unit, control unit, and arithmetical and logical unit. Memory unit, as you can ask me now why memory unit here. See, memory unit means it's not the entire memory of your computer. We are going to see the memory part also in the later slides, in which you will understand more better. So memory are again of different types. Now what memory you see here is nothing but you can call it as a cache memory, or you can call it as a registers, which resides within the processor. They are not outside of your processor. Okay, to access the instructions or to execute the instruction or temporarily hold the instruction. So to do these tasks, these registers and cache memory is going to help the processor. Whereas control unit and arithmetical and logical unit, these are arithmetic. First let me tell you arithmetical and logical unit. Now arithmetical and logical unit is helping you to perform arithmetic operations like add, subtract, multiplication. So these are the arithmetical functions which a computer is going to perform using this arithmetical unit. Logical unit means in computer we have some gates like AND gate, OR gate, NOT gate, which are something called as logical unit. So it is going to also make use of this logical unit. Okay, arithmetical and logical unit is going to help the processor to perform arithmetical and logical functions. Okay, memory unit is going to help the processor to hold the memory, to store the, sorry, to hold the instruction or to store the instruction. Whereas control unit is something like who is controlling all the other parts of your computer. Means not only control unit to memory or not only control unit to ALU. Control unit is controlling the flow of the addresses, the flow of the controls, the flow of the data from input unit to output, from memory to ALU, ALU to memory, or etc. So control unit is something responsible to manage all the other units flow of data, address or controls, right? Then comes the output unit. Now output unit, as a name itself indicates, as it is an output unit, which is where we are going to see the result. Okay, we are going to see whatever task we have assigned, we will be able to see the result of it, right? So that is what an output is. So output, you can take an example as an a monitor, printer, or speakers. These all are the examples for output units. So I hope you understood the basic concept of an or a basic structure of a computer, where input unit is there, CPU is there, in which control unit, ALU unit, memory unit is there. Then we have a final output unit, and you can see the arrow mark. Now you can cannot reverse this arrow mark from output unit to CPU, because our screen, means the monitor, is not actually giving any instruction to the processor, right? So as you can see, input means from the user we are getting the data, and once it is processed, once the input is processed, after doing some transactions and the execution of the instruction, the result is going to be sent to the output, right? So this is the basic structure of an computer. So input unit. Now, as I said, input unit. Now, input unit is going to allow the computer to interact with the users. Users can give the requirement by providing the data and the instructions. What do you mean by data and instruction? Now, for example, if a user wants to add a simple, let's take an example of a simple calculation. I want to add 10 plus 20. Okay, now that of course we can add this as like by ourselves also, but let's take example, if we give this task to a computer, how it is going to perform. So now in this, let me show you how it is going to perform. Now MS Paint is also visible to you all, everyone?
Yes.
Yes. Okay, so let me just quickly draw this. Okay, now this is input unit. This is output unit, and this is my CPU of the computer, and this is the memory unit of the computer. Okay, and in this only we have two things, two important things. ALU, and this is CU. Okay, now we are talking about this input unit. Now input unit means, now for example, as I said, I want to add 10 plus 20. I know the result is what? It is 30. But how it is going to be inputted to the computer, how it is going to process it, and how it is going to give the output, that part we are going to see. Okay, so now input unit is the one using which the user is going to give the inputs. So what exactly inputs I'm going to give to the computer? I'm going to give two numbers, that is two data numbers, 10 comma 20. right? I want to give these numbers to the computer, as well as with this I am going to also give one instruction to the computer that 10 and 20 are the data on which this instruction needs to be performed. This is my data, this is my instruction. So what exactly I want to do with this data? I want to add this data. I want to add these two numbers. So this is what are inputs that we give it from this particular input unit to the CPU. Okay. Now, when we give this type of an input unit to the CPU, what exactly happens? Now CPU is a processor which know how to actually execute everything, but it cannot hold anything or store anything by itself. So for that, we need a memory unit. So when I am giving an instruction 10, oh sorry, when I am giving the data 10 and 20, where it is temporarily is going to be hold, it is in the memory of the CPU. Temporarily it will be holded here. So now next, plus. Plus is an instruction. Now, plus means add. Now, which is going to be performed? Which unit is responsible to perform this particular task? Can someone tell me? Yes, please. Can someone tell me who is going to perform plus or an add here? It's a AL unit, right? Arithmetical and logical unit. So my data is here, but the instruction is here. So the memory is going to give the data or the input to this particular ALU that arithmetical operation needs to be performed, that is add. So now here what is happening? The arithmetic unit is performing 10 plus 20. Now, when it is performing, the result is calculated. That is 10 plus 20, the result is 30. Now, the output is available, but where it is temporarily being hold, it is temporarily being hold, or this ALU is going to temporarily again give this input or give these things to your memory to hold it. That 30 is the result of the input whatever is given by the user. So now this 30 needs to be displayed to the user, that is using a output unit, right? So output unit can be our printer, it can be the monitor, it can be speaker, etc., right? So this is what is going to happen when we give any input, whether we give data or instruction, that input unit is going to help the CPU to accept the instructions and the data from the user. I hope it is clear for everyone. This is going to allow to interact with the user. See, what are the examples of input unit? We can give the input unit inputs to the computer using keyboard, using mouse, using scanner or webcams, right? So these all are the input. Now input is going to be understood into the computer understandable language. Now one more point. Now I have given here 10, given here 20, given plus sign. So which is something a user understandable language. Means I will understand, you will understand. What is 10? What is 20, what is decimal number, what is plus, minus, carry, everything we understand because we have studied in this type of a language. But how computer will understand? Computer will not understand our language. It doesn't know what do you mean by English. It doesn't know what is the meaning of this 10 comma 20 and plus. So the language what we use to give is something called as a high level language. High level language means the language or the statements which are designed and used by users like us. Okay, and then these languages are going to be converted into the machine understandable language. Now, machine means our computer. Now, our computer understands which language? Can anyone tell me? Computer understands which language? It understands binary language. Binary language is also called as machine level language, which is in terms of ones and zeros, right? So these ones and zeros will nothing but going to be understood, and this conversion will be done by your computer itself. So that conversion is always there because it will not understand high level language, and we don't understand machine level language because it is too much complex and lengthy to remember and to process it, right? Yes. So output unit, this unit is going to display the process data or the results which are given by the processor. So which includes, as I have already told you, some examples for output unit is monitor, printer, speakers, everything, right? Next, memory unit. Now, memory unit is going to store or hold the data and instruction which is going to be processed. As I have told you in this, see, now in this scenario, I don't wanted a computer to store my result, but I want my computer to process my result. But to process this instruction or to store this instruction, for both reasons, we need a memory unit, right? So, memory unit is 100% mandatory for a computer to boot, to start the computer, as well as to process any instruction, right? So, that is what a memory unit is. Now, in memory unit, if we go in deeper, we have a RAM and we have ROM. RAM full form is random access memory, which is a very short storage memory, which is very much active and very much fast. Whereas ROM is read-only memory, which is going to help to store some essential instruction and that are not volatile. Not volatile means this particular instruction which you store it in the ROM are something permanent, which is not going to be deleted or erased even when you shut down the computer or even when the power goes off suddenly. But in case of RAM, if you are typing something, suppose in case the power goes off, then immediately the data or the instructions which are there in the RAM will be deleted immediately, right, without the user intervention. So this is memory, and we are going to discuss this memory unit separately in the upcoming slides. Okay, then we have ALU. So this unit is going to perform, as I said already, arithmetical and logical operations on the data. It is a core component of the CPU because this is going to perform all the instruction executions. It is a very much responsible for a responsible component of a CPU of an entire computer system. Then comes the control unit. So whatever is coming inside the computer, whatever is processing, whatever is going to memory unit, whatever is coming from memory unit, what is going to output unit, these all things needs to be controlled, and control unit is something doing this type of a task. Control unit is going to direct all the other units that where you should go, what you should do, when you should do. Okay, so that's why control unit is very much important. Along with that, see, it is also going to fetch instructions from the memory, decoding them as well as helping them to execute it. So this is the memory unit and ALU unit and control unit. Then comes CPU. See, what is this called as? The CPU is the brain of the computer, coordinating all the operations of the controller, of the system. It also has a ALU, it also has a control unit. So brain of the computer means because it is only handling the maximum task of your entire computer, taking input, processing it, giving output, storing, holding, everything will be handled and taken care by your CPU. So that is why it is called as the brain of the computer. Imagine if we are, let's say, not able to remember anything, not able to calculate, let's say 2 plus 5. So how do you be treated, or how it will be the impact, right? So brain is like how it is important for us to remember to survive. The same way the CPU is important for a computer system. Okay, so now till now we have discussed everything, like what are the some examples for input unit, that is keyboard mouse. What are some examples for output unit, that is printer monitor. We have a memory, we have a CPU processor, we have AL unit, CU, and etc. Now all these needs to be connected at one place. Okay, now what is that place? Now that place is the motherboard. The motherboard is the main circuit board that connects all the other components of the computer. It is going to give data as well as power to flow to each and every device. Means from a simple keyboard and mouse to hard disk, power supply, everything, whatever you see outside of your computer or the internal components of your computer, everything will be directly or indirectly connected to the motherboard, which is also called as a main circuit board, which is also called as a system board, because without that nothing is going to happen. If you don't, like for example, now you might have used a pen drive. Now pen drive you connect to the back panel of your computer, right? CPU box to the USB port, right? Now where is that USB port connected? Internally in the computer, it is a port which is connected directly to the motherboard. Means what? Externally pen drive you are attaching, it is actually connecting internally directly to the motherboard. Otherwise nothing is possible. Means until and unless your motherboard detects any hardware which you have connected, maybe internally, maybe externally, until and unless the motherboard is going to detect it, your processor will not come to know. So motherboard is again a very important device. Now to explain this or to see this, we don't see it outside. We see what? When I say a computer, what does comes in your mind? A input unit, that is keyboard, a mouse, a monitor, a CPU box, right? Or a power supply unit, if you go in deep, right? This is just what the image we have of in a computer. But in the background, motherboard is again one very important circuit of the computer, using which all the devices are connected, right? So this is how the organization of a computer consists of these all important parts. Okay, so now you can see the same diagram with some examples. Input unit, I said, that is input device, keyboard, mouse, scanner, joystick. Now joystick is a device which is used to play games. Usually means most of the time it is used to play the games. So that device is called as a joystick. So these are the some examples for input unit. Now this is a structure of your computer where control unit and ALU always requires a memory to give. See what you are giving input as data, but you are giving information as an output. Now where you are giving this output? To monitor, to printer, to speakers, or the headphones. Whatever these devices are there, these are something called as an output devices. Okay. Then we will see some more things about a CPU, because this is the most important component. And what I told you, CPU is also something as in a brain of a computer, right? CPU full form is Central Processing Unit. Now, it is a brain of a computer, as I have already told you, because it is responsible to execute the instruction and the data. It is a electronic circuit which is nothing but comes in a chip format. Chip means one IC format, integrated circuit IC format, which is going to be inserted on the motherboard, which is responsible to execute the operating system also, applications also, and your all other computer operations also. Means it is something responsible for all. So let's see what are the main responsible of the CPU. So the first main responsibility is instruction execution. Okay, means so the CPU is going to fetch. Fetch means it is going to give one input instruction from the memory. It is going to decode them. It is going to execute them and then performing any calculation required. Then data it is going to give into the format how the user is going to understand, and then control unit is going to control all these operations. Okay, so as if I take this same example, when I gave 10 and 20 data as an input plus as an instruction that I want to add 10 plus 20, this is my task. When I give this, I'm just sitting idle, I'm just sitting blank. I don't know what is happening in the background of a computer. But when we just give 10 plus 20, or when we give, let's say, 56,888 plus 60,868, any number, okay, any a simple number to a complex number, not only again mathematical calculation, you give any task to a computer, it is going to execute everything in an instruction execution cycle, in which when any instruction comes from the computer, it is going to decode them. Now, what do you mean by decode? Decode means it is something understood. It should be something understood by your computer. As I said, high level languages like what inputs we give as a user, your computer doesn't understand that language. It needs to be transmitted or translated, should be in its own understandable language. That is which language? Anyone? Machine language. That is binary language, right? So this binary language, it is going to decode them, perform the calculation, and then it is going to give the data. Okay, so when it is processing the data, it also need arithmetical logical unit, also input on it, output unit. Because if doesn't have a ALU, doesn't have input unit, how it is going to accept? If doesn't have a output unit, how it is going to show the output, where it is going to show the output, right? These all things are there, so it is important. It is also performs one more important function, that is system control. Now system control means it is going to manage the flow of every instruction, as I said, from where it is coming, where it is going, what should be done at what time. This control of every address, control of every data, or control of every flow from all other units are going to be handled by the CPU. Okay, and operating system and application is one more. Now operating system and application, again we will see in detail. Now I'll tell you. Now operating system is something which is mandatory software for your computer. If you have input unit, I have output units for my computer, CPU is very much high speed, but if you don't install a operating system, it is as good as a dead machine. You will not be able to do any single operation into your computer if you don't have a operating system into it. So operating system is very much important and a mandatory software, whereas application is something which you can see it is an additional software. I will come to that point, what do you mean by operating system and what do you mean by applications. Now for this you have to understand that the CPU is again responsible to handle this operating system. Along with that, as I have told you already, control unit is one component, ALU is another, and one more is registers. And there is something new here called as a cache memory, registers and cache memory. Now see, in this diagram, what I have told you that memory is part of the CPU. See, this entire thing is a CPU. In CPU only you have ALU, you have CU, plus you have memory unit. So what is that memory? Is it a RAM slot or is it a hard disk? No, it is none of them. What it is? It is registers and cache memory. Now see, registers and cache memory is something a memory which is stored within the processor. Means when your CPU is manufacturing in the factory, that time only they have built it with ALU plus CU plus memory. Which memory? Registers are available, cache memory, which is very small in size but very much faster than all the other memory. Now, why it is required? Is it required? Yes, it is required. And due to these registers and the cache memory, the CPU is performing very much faster than the olden days, right? So this is what you find inside the CPU. The memory, what I said, is nothing but registers and cache memory. Okay. So the CPU is often said as a brain of the computer, as I have already told you. Okay. So just give me one moment. I'll just have my water. Yes. So as I said, it executes the instruction, it takes the input, it decodes it, understands the or converts it into the computer understandable. So how exactly it happens? So let's see a simple diagram for it. Now this is the CPU. This is how it looks like. Processor. Okay. When see this is an execution cycle in which you give any instruction that will be, see what is the first step? It is going to be fetch. Fetch means it is going to be given to the processor. Once it is given, it is going to be decode because it doesn't understand what you are talking about, what you are saying, what you are typing, because everything is in the form of high level language. So it is going to convert it into it's a machine level language. So that is decode. Once it decodes, okay, now it understands, okay, the user wants to add 10 and 20. Then it is going to actually perform. That is the third step, execute cycle. So when it performs, then memory is there to store or to hold or to display. Okay, it depends. So this is how a instruction cycle is going to be there, in which there are four main steps. One is fetch, decode, execute, and store. Okay. Now this is one normal and regular instruction cycle which is going to be there. But can you see something here? Check for interrupt. Now what do you mean by interrupt? Now I'll tell you one real time example. See, now we have already given my computer a task to display this ppt to you. Okay, so what is my computer processor is doing? On the monitor screen it is displaying this particular slide for me, because this is what the instruction is given by me to the processor. But suddenly, what as an user I think of, let's say listening to the music, or let's say I click on the start menu. Okay, now what is happening in the background? Now the processor, which was busy showing the slide on the screen, has stopped that task and given attention to what the user is requested for. Means I have disturbed it. What was the instruction was executing earlier, the now CPU is focusing on what is now I am giving. Now, once I perform, or let's say once I start, now suppose if I press the button again, the start menu is vanished. So now again it is going back to my screen. So interrupt here means not exactly the disturbance. Interrupt means any service which is required by the user when it was actually busy executing one cycle. That's why the name is given as an interrupt here. Because whatever it was doing earlier, it will stop it for time being. It will give attention to you, what you have, what you are trying to say, or what other instruction or users data you have given. According to that it is going to give the output, and then again it comes back, or you can say resumes its previous task, right? So this is what exactly the instruction cycle is there. Now the same cycle I'll show you with the, see, fetch is the step one, means this is going to be fetched from the RAM, because whatever instruction and data it is giving, it will be temporarily holded in the RAM or in the primary memory, and then it is going to step 2, that is decode. It is going to be understood in a different understandable, that is a binary understandable format. That is, the instruction and data is going to be converted into the machine level language. Then exactly the calculations is going to happen, that is execution. And the fourth step is store. So where it is going to store? Again in the RAM, which is in the main memory, which can hold or store the data or instruction which are given by your computer, right? So this is what exactly a computer instruction cycle is going to be there. Okay, this is the block diagram, you can say. This is just to simply understand by you all how exactly it goes on. Okay, so now let's focus on only what is memory. Okay, now we also have a memory. We are human beings, so memory is important for us, right? The same way the memory is important for computer also. Now before this only I have told you how memory is important to the computer to execute any data or instructions. Now let's see what is memory. Now it is used to store data and instruction. It is also available in storage devices where you can store the data, process data temporarily for so many years. Okay, and it can also store both the input and output. What input you are giving, what output you are displaying. It can hold, it can store anything, whatever you will be asked for. Okay, so primary memory, secondary memory, these are the two main important types of it. Okay, primary memory is something very much faster. Secondary memory is slower. Slower means what? 1 hour or 2 hours slower? No, just in few milliseconds. Few, only few, not even 1 milliseconds maybe. Okay, maybe in point it is, or maybe in sometimes it is slower in milliseconds only. Okay, so computer requires both primary memory and secondary memory. Okay, so now let's see what is a memory organization, or what is primary memory and secondary memory. So primary memory, in which RAM is there, cache is there. Can anyone tell me what is the full form of a RAM? Yes, everyone, what is the full form of a RAM? RAM is random access memory, which is here as serving as primary memory. Okay, whereas cache is again one more memory, all cache is again one more memory which is serving as a primary memory. Now these are very much temporary but very much fast, immediate processing, but it is a very short in the storage. Okay, means it is not something available like you want to store, let's say, TB data, GB data, hundreds of GB, 200s of GB. No, it is not available in that much data storage capacity. It is with a very limited capacity. Okay, but very fast. Everything it executes in just nanoseconds. Stores the data currently what is processing and what is there in the instruction execution cycle. That is primary memory. Now primary memory best example is random access memory, that is RAM, and one more is cache memory. And the other side, if you see, it is a secondary memory. Now secondary memory, in which the examples are HDD. HDD means hard disk drive. SSD means solid state devices. USB is universal serial bus, means the hard disk. This is another new type of a hard disk which is available in the market. The USB means for which you connect pen drives. These all comes in the secondary, means they are going to store your data permanently for longer time. Means until and unless you delete it manually by yourself, the data is always there. Okay, but it is slower compared to primary. As I said, slower means that doesn't mean it is 1 or 2 hours slower. Slower means it is just in few milliseconds, it is slower than primary. Okay, where why it is used, it is going to use for storing files for a longer time, operating system, programs, for backup data. So for all these purpose we need secondary memory. Okay, now one question. Now primary memory is important or secondary memory is important for a computer? Can anyone tell me? What do you think? Hmm? Which memory is most important for a computer? Both the memories are important. Primary memory plus secondary memory, because your computer, I'll take an example. Now let's take a RAM. Now RAM, if you take it off, let's say 4 GB RAM you have for your computer. Okay, because as I said, it comes with a limited capacity. So RAM of 4 GB is available. Now let's take the other side, hard disk. Hard disk is available, let's say, in 500 GB. Okay, now I connected my 4 GB RAM slot. I connected the hard disk to the computer. Now in RAM, the right now currently working instructions are there, whereas in hard disk the operating system is stored, operating system is going to be loaded, both the things are there. Now when these two things are already connected to your computer will boot successfully. Boot means starting of your computer. Booting procedure is the starting or loading the operating system files from the hard disk to the main memory. That process is called as a booting process. Okay, now what I will do, let's take out one memory from the computer. Means what? I will disconnect a 4 GB RAM from the computer, but 500 GB hard disk is still available with the computer. Okay, now in this situation, your computer will start or will not? Can anyone tell me? If I remove 4 GB RAM and if I have, okay, if I remove 4 GB RAM and let's say if I have an 500 GB hard disk, the computer will start? No, it will not start. It is a mandatory memory for your computer. One long beep will come if you don't, or let's say your RAM is disconnected, or let's say the dust is there on your RAM. It will give one long beep when you start the computer. So it is important. Now second, what I will do, I'll keep 4 GB RAM as it is important, and I'll remove 500 GB hard disk. Now your computer will start? No, still your computer will not start. Why? Because when it will start means it will boot. Boot means it will load the files of your operating system, which is a mandatory software. And it doesn't find anything because operating system is something saved or loaded into the hard disk drive. So where it will not find any loading files of OS, how your computer will start and do? You will not be able to do. So in short, what I want to say is primary memory and secondary memory, both are mandatory for your computer. Both are equally compulsory for your computer. So now if you see memory organization, primary memory is also called as volatile memory and secondary memory is also called as a non-volatile memory. Volatile means also, it is why it is called volatile, because it loses its data when the power is switched off. Whereas non-volatile means it's a permanent storage, means even if the power goes off, the data what you have kept in a secondary storage is still available. Means as I said, until and unless you delete it, it is not going to be deleted. It is permanently going to be saved in the secondary data storage, which is also called as non-volatile. Volatile means which can be erased when the power is switched off. It means it's a temporary. Non-volatile means it's a permanent storage. Now this is how the memory hierarchy is. Okay. Now in this, the first and foremost comes is the register. Registers are the memory which are very fast in processing but have a limited space. Cache memory is the second in the memory organization, which are faster than main memory, but again the capacity of cache memory is more than the register. Then comes the main memory. Main memory means the RAM, random access memory. The RAM is one which comes here in the main memory. Now main memory is having more capacity than the cache memory and the register. Okay. And then comes the secondary memory, which is also called as the auxiliary memory. Secondary memory is also called as auxiliary memory, in which magnetic disk means the hard disk, or earlier there were magnetic tapes which are used for the backup purposes are there. So magnetic disk and magnetic tapes both comes in secondary memory, which stores the data permanently. So the capacity of this to store the data is much more than main cache and register. Means here, as you can see this pyramid, this triangle, as it goes up, means what? The accessing time required to access this memory is very less. Means as you can see in the hierarchy, first one is what? Register. Means CPU can access it very faster than cache memory. Cache memory is accessed faster than main memory. Main memory is accessed faster than your magnetic devices, means your secondary memory. So this is how access time is going to be reduced as you go up in the pyramid. But the data storage, if you see, there should be a one more arrow mark here, like this, means as in when you go down the pyramid, down to this triangle, the data storage is going to be increased. Means the capacity of register is lesser than cache. Main memory is having more capacity than cache. Magnetic disk are having more capacity than main memory. So this is how a memory hierarchy or an organization is there. Usually register, I am repeating again, registers and cache memory are something there inside the CPU, whereas main memory is RAM, that is primary memory, and whereas secondary memory is the hard disk. See, primary memory, secondary memory. A simple table is there to understand what is the purpose. It is used to store the data temporarily. What data and instructions by the CPU, it will be used for that. Whereas purpose of the secondary is when you want to store the data and programs for a longer time, then and for a, let's say you have a huge data, then definitely you should have a secondary memory. And what is the speed of accessing this memory from the CPU? CPU can very fastly access this particular primary memory because these are easily available and directly available to the CPU. Whereas these are slow compared to primary because these are accessed through your input and output channels. Whereas primary memory is also called as I said, volatile, because here the data is not permanently saved. It is saved temporarily. Whereas secondary memory is something a non-volatile, means here the data is saved until and unless you delete it. Okay. It comes in a smaller capacity, as I said. It doesn't have, let's say, it almost for a regular computer, it 4 GB to 16 GB is maximum RAM capacity is there, which is more than sufficient. Whereas if you see hard disk drive, see 256 GB, 500 GB, 1000 GB. Now at least you are getting also in TBs, gigabytes, right? Terabytes. Now, the examples for primary memory is RAM and the cache memory, whereas example for the hard disk or sorry, secondary memory is hard disk drive, solid state devices, USB drives for which you connect a pen drive, because pen drive is also a permanent storage. Earlier to this, CD, DVD were also used. CD means compact disc, DVD means digital versatile disc. Earlier, CD, DVDs were also there, which was used to store the data for a longer time. But now again, pen drive has actually eliminated CD DVD usage, because to insert a CD DVD you need a separate player of it, CD DVD player. But to insert a pen drive you need just one USB port. That's why now it is eliminated, right? Then comes what is hardware and what is software. So computer is part of input, output, CPU, memory. So there are something here as in a hardware. There are something here as a software. If you see hardware, hardware means what? In simple statements, if you see hardware means it's a physical components of your computer, motherboard, CPU, that is processor chip, keyboard, mouse, IC, hard disk, means which is physically available as in a device. Maybe outside of your computer or maybe internally into your computer. Means outside in structure also, if it is there, like a keyboard is, you can see, pen drive you can see, monitor you can see. But internally if you see, motherboard is also there, capacitors on the motherboards are there, registers are there, CMOS battery is there, hard disk drive connections are there, power supply is there. These all are the devices which are physically available and something occupies space. Okay, so that comes as in a hardware. Whereas
Madam,
software,
just a minute. Sorry to disturb.
yes sir.
Uh, you can convert to institute's internet connection. It has now started.
Okay, it's okay now sir, I will continue, no problem
Uh,
in this. And my voice is not breaking, right?
Not breaking, but then your internet will get exhausted.
Okay, just a minute. I'll just shift
You
it
can
to,
switch over.
yes. Yes, we were here into the hardware and software. So software is a set of programs to perform a specific task. Okay. So in software, operating system is one which is very, very much important, which is mandatory to the computer processor to process. So OS is also a software, and there are something called as applications which are also as in a software. So which are available. Now, what do you mean by OS and what do you mean by applications? We will see in the next slide. So let's see what is hardware. As I told you, hardware means is not just the devices or the components which you see outside of a computer. Hardware are also the device which are internally in the computer, which occupy some space, which are physically available as in a device or on the motherboard, you can see. So in which CPU is there, RAM is there, hard drive is there, monitor, graphic card, keyboard, RAM slot, CMOS battery, the ICs, South Bridge, North Bridge, which are also as an IC on the motherboard. These all comes as an hardware. And we know already, CPU is brain of the computer, is performs execution, RAM is for temporary storage, hard drive is for permanent storage for a large amount of a data, monitor is a output unit which displays, keyboard and mouse is an input device for interacting or giving inputs to the computer, graphics card is for the image and video, image and the video to display it in a better quality. Graphics card is there, right? So these all, graphics card, or you can take a sound card, you can take a network card. These all are the examples for hardware. Hardware means what? Hardware means the physical components of a computer which are easily visible, occupy some space, and which you can touch. In simple language, the devices which you can touch is called as a hardware. Then we have a software. Now in software, we have operating system. Means, can you see here what is written? Core software. Core means the main, without which nothing is going to be started. Okay. Like now, before we structure a home, first the platform is given to, like whenever you are building a home, first the platform is given to that particular home. Without platform, the home cannot be built, or if it, even if it is built, it is not strong. But in case of operating system, it is a mandatory, it is a core software, without which nothing is going to be possible, right? So the core software, the core operating system is going to ensure all the hardware resources. It is going to work as a platform. And what are the examples who as an operating system available in the market today? There are very famous operating systems, like we know Microsoft Windows is there. In Linux, again, there are many versions. Mac operating system is there, right? And nowadays we use a mobile. In every mobile you find a OS. So that is a operating system, without which your mobile will not start. The same way the computer will not start. Everything you have, but you don't have a OS installed in it, whether it is Windows, Linux, doesn't matter. But if you have a OS, it is going to be run. If you don't have a OS, it is not going to be run, right? Then application software. Application software means which are additional softwares, which are not mandatory, like Microsoft Word, Chrome, Photoshop. Okay, means which a user is using to perform a particular specific task, like a Microsoft Word. Now right now I'm using a PowerPoint. Now PowerPoint I want it for my purpose, because I want to create PPTs and I want to display it to you. So this is application software which are not mandatory. Means in your computer there is no MS Office, there is no Chrome, still your computer will start. But if your computer doesn't have an operating system, it will not start. It is a mandatory one. Application is not mandatory. But nowadays we do so many multiple tasks in our computer where we require these softwares as well, right? Then we have a system software. The system software is going to help to communicate, or let's say it is going to behave as an interface between the hardware and the software resources. Means how your hard drive will come to know that it should loaded into the main memory, the OS. How your software, the let's say the Microsoft Word, should know, or will be knowing it should be loaded into the memory now for the display purpose. So this communication between a hardware and a software is done by system software. Okay, now example for that you can take it as a BIOS, basic input output system, which is also called as a firmware. 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 Firmware is behaving as an interface, behaving as a communication between a hardware and software, which is a best example you can give it for system software. I hope you understood, everyone. Software, in that what is operating system, what is application software, and what is system software. Now these are some examples. See, hardware we have mouse, hard disk drive, printer, speaker, keyboard, headphone, system box, monitor, or any device within this is also a hardware, because that also requires some space to hold or to keep or to connect, right? Whereas software means any application what we are using, like it can be a browser, it can be a internet browser, it can be any utility like Microsoft Word, Office, Excel, and it can be a OS as well. So in OS means, as here Microsoft is there, it can be a Linux OS also, it can be a Mac OS also, but which is very important. Now we have something called as a backup device, because as we completed some basics of computer where we understood what is input, output, memory, what are the hardware, software devices, input, the example for memory organization, difference between primary and secondary memory. Now let's come back to backup. Now, keeping a backup of the data is important. Yes, anyone can tell me, is it important? Yes, it is important. Nowadays, we store n number of things in our computer. Nowadays, at least we don't only store it in our computer, we are also utilizing cloud storage. Means it is now not restricted that we save our data only in our hard disk or only in our the pen drive. We also use the cloud storages. Like you use a Gmail, everyone. Now, if you have a Gmail ID, you have a 15 GB free space for your account to store some data or documents. Now, this 15 GB is available for everyone, which is free of cost. Now, let's say I have saved my resume today in my Gmail ID. It is something saved in Google Drive. Now, what is Google Drive? Is nothing but a cloud storage. Because if you want to access your resume, let's say from India today, let's say from America tomorrow, you can access it because it is not stored locally in your computer or pen drive. It is stored something in the cloud, which is accessible to everyone or everywhere. But not only that, nowadays we have a external hard drives, pen drives. USB flash drive is nothing but pen drive, network attached storage, which is also called as NAS. Means how a computer is can be connected to the network. The same way, a storage means a hard disk also can be independently connected to the network. That device is called as network attached storage. And in the earlier like days, we were having CD, DVDs, and tape drives, which were looking similar. Tape drives were looking similar to the hard disk drive, but earlier it was used as an backup devices. Okay. Now, external backup devices means there are some devices which are working as portable, plug and play. Means easily you connect, you store, and you remove it. Okay, you don't need to turn off your computer, restart your computer, don't need to do. For example, pen drive. Now I want to save one file as in a backup copy. So that file I will be, let's say, connecting my pen drive, save the file and disconnect the pen drive. My job is done. So now it is like in a plug and play device. It is as easy as in a hard disk. Okay, means how you connect a pen drive, nowadays you can also connect a hard disk like this. Connect it externally, save the data, and then take it out like a pen drive. Okay, so that is called as external hard disk. Because internal means what? For which you need to open the cabinet of your system box, you need to connect the cable of the hard disk drive on the motherboard, then it will start. Okay, that is internal hard disk. But we don't take backup in the internal hard disk, because if hard disk fails, the backup is also fails. So always keep a backup in a different drive. It can be your external hard drive, it can be your pen drive, right, which is very much inexpensive and affordable for every single user. Very convenient method of keeping the backup. And as I said, NAS, network attached storage, is also available nowadays, where you have a dedicated storage device which will do only the job of keeping the backup files. I want anything, let's say I have lost my one file, this backup will help me to recover my data which is deleted. So why we keep backups? Backup we keeps to recover our files. Cloud storage, like I told you example, Google Drive, Dropbox, OneDrive, these all are the examples for cloud storage. And that too we can access it with free of cost. Definitely there are paid services also in which you will get much more capacity than the 15 GB. DVD, CDs, nowadays we don't use it. Magnetic tape, nowadays we don't use, but earlier, yes, these were also there to keep the backup of the system. And there are some backup softwares which will also not only save your data as in a backup copy, but also will help you to secure your data by encrypting it, by compression it. Can you see here encryption and compression? Encryption means converting a plain text to a coded text, whereas decryption means converting a coded text to a plain text. Now, why this needs to be done? Because if anyone get access to your backup device, will not be able to access your files because you secured it with encryption algorithm. Compression means, let's say now I am taking a backup of 20 GB folder. When I keep it as in a backup copy, it should not occupy 20 GB. It should somewhere occupy 8 to 10 GB. Means I am saving the other 10 GB for the other storages. Means compression will help to reduce the size of the file, but it never deletes or reduces the data within that file. Okay, so this was about a backup devices in the computer. Then basics of internet. So basics of internet means internet. Now before we go to internet, what is network? Network and internet is same or different? Of course it is different. Network is the connections of a computers which are connected to each other to share information and resources. Okay, means like in a computer in a lab, let's say we connect the devices in the network, we can share any data, any resources from one to other. That is a network. But if I want to connect multiple networks like this, is it possible? Yes, it is possible. So when you say a internet means it is the collection of multiple different networks. Means internet means it's not that you are connecting only one lab, or let's say you are connecting only your home network. You are connecting multiple labs, multiple home network, multiple offices to one central location. That is a internet. Okay, now as you can see, it is made up with many networks. Maybe they are private, maybe they are public, maybe they are related to academic, business or government, defense, etc. Because nowadays, now right now, me and you are also connected with the help of internet. If there is no internet today, we would have not taken this, or this is it is not possible to take this online session, right? So internet is that much important. Not for the sessions, nowadays we use email for every communication purpose. For every communication we do it through email. That is something very important, and the email doesn't work without the help of our internet. Now if you see some history of a internet, it was something designed in 1969, and the first net internet which was designed, what something called as an ARPANET. ARPANET, that is Advanced Research Project Agency Network, which is in short called as an ARPANET, which is designed and implemented by University of California, Los Angeles, Stanford Research Institute in 1969, as I said. Now how does it look, or how does it you can see it? See, it is something visible like this. Like now every person has a name, every computer has a name. Like that, every internet website has a address, which is called as an a website address. Website. Okay, can you see here http is there, and here https is there. Earlier, only HTTP was there, but now it is changed to HTTPS. Now, what is the difference? Now, first of all, what is the full form of HTTP? May I know? Anyone? What is full form of HTTP? HTTP is Hypertext Transfer Protocol. Now, hypertext transfer protocol is used to upload or download any web page. Whereas HTTPS means hypertext transfer protocol plus S means here SSL, secure socket layer. Now SSL will help to secure the web pages which are available in the internet, because see, internet means it can be accessed by anyone, so it has to be secured, right? Nowadays nowadays we see my data is hacked, my money is stolen, we got a call from foreigner ransomware. So we are coming across so many cyber attacks nowadays, right? So it has to be secured. So nowadays web pages are something used as not only HTTP, as in a HTTPS. Okay, so this is about a web page. But let's say if I want to upload and download a file than a web page, I don't want to go for a web page, I want to, let's say, upload and download a file. So is the same protocol is going to be used? HTTP? No. FTP will be used. FTP means file transfer protocol, which is used to upload and download the files. TFTP is there, Tribal File Transfer Protocol, which is used to upload and download the data. So, to do any task in the internet, we have protocols. Protocols means rules and regulations. Rules and regulations for computer. HTTP means it's a web page. FTP means it's a file. Now, the same way, let's say it is SMTP. SMTP full form is Simple Mail Transfer Protocol. Now, SMTP means it is used to transfer the mail, whereas POP means it is Post Office Protocol, where it is going to used for receiving a mail. So, receiving POP, sending SMTP. So, like that, for everything there is a protocol in internet. Okay, so how does the internet work? As I said, everything works on this TCP/IP, transmission control protocol slash internet protocol. Now, what is this? Now, this is a actually protocol suite. Suite means it is not just one protocol here. Now, in TCP/IP, we have 4 layers. In every layer, we have multiple protocols. Every protocol is responsible for something. Like I said, HTTP responsible for web page. FTP, TFTP responsible for file uploading and downloading. DNS responsible for domain name system conversion from name to IP, IP to name. SMTP to send the mail. POP to receive the mail. Like that, there are n number of protocols which are available, or you can say it is a protocol suite. What is that suite? It is TCP/IP. Now, internet is going to be sent the data in by breaking, or let's say by dividing the messages into the smaller pieces, which are called as packets. Now these packets will be routed by routers. Now router is a device. Router is a internetworking device. Means router will help the users to connect to the internet. Router is not used to connect to the second computer from the first computer. But router is used to connect a computer, one computer from, let's say, Pune to one computer, let's say, from Australia. Means when we have uh, different networks to communicate, we need a router. Okay. But in a local, let's say we have a one lab. In lab, I have 50 computers, and to connect that 50 computers, I don't need a router. In that case, I need a switch device, which is used to connect locally to the computers, whereas router is used to connect to the different network wherever the user is there, maybe outside the lab, maybe within Pune, or maybe outside Pune, India, XYZ. Okay. Now whenever we access this internet, there are several computers which are behaving as a servers, which have which are having a large amount of a data storage than the other regular computers what we use, or standard computers what they use, right? So to access this multiple, like Google is a one web server. Okay, now let's say for example I want to see how internet speed is there. I will go for Google and I'll just type it and I'll get my result. So like that we have several web servers today which are working for us. Okay, now what can we do with internet? We can do so many things, like we can send and receive emails, we can list n number of servers, we can connect to n number of servers, news group. We use telnet, gopher and ftp. Telnet or gopher, ftp is something when you want to connect to the remote computer, maybe to upload and download, or to give them the access, or to show them something. When we want to connect remote, we use telnet, gopher and ftp for files, and everything will be accessed through this www, that is world wide web. World wide web is something, one collection of all the web servers, means how many web servers are there in this world. All those web servers are there connected to this www, which is, you can call it as a bunch of all the web servers. Nowadays we can make a phone calls, we can make a video calls, we can share files, we can share resources, we can do so many things today with the help of internet. We can run businesses, not only the enterprise level businesses. We can run, I can start my businesses with the help of an internet today. Let's say I create a WhatsApp group and I will add some members and I will, let's say, sell some products related to beauty or related to hair or xyz. So internet is helping every a normal regular person to every IT professionals today. Okay, so internet is everywhere. Without internet, definitely there are so many things which we may shut down today if there is no internet, right? So internet is something, connection of multiple different networks. For internet we need a router to connect, but for a local network we don't need a router, we need a switch device, right? So everyone, I hope you are still there. Yeah. So now this is what the basics of a computer. Now let me take you to some of the MCQs related to this same syllabus. Okay, so let us go through it. Okay, now for this you have to tell me the answer. Everyone, you have to tell me. I can see three of you here. So try to give the answer. No problem. I am there to help you. Okay, so let's see the first question. Which component of a computer is responsible for executing instruction? See, what are the options? CPU, input output device, memory, and backup device. Can you give me the answer? Yes. Yes, everyone. So the answer here is CPU. Central Processing Unit is something responsible to execute any instruction in the computer. Then, second question. What is the main function of ALU, that is arithmetical and logical unit in the CPU? Why this ALU unit is used? Definitely to perform arithmetical and logical operations, ALU operations, right? Then next question. Which type of a memory is volatile and loses its data when the computer is turned off? Can someone tell me whether it is a hard disk, RAM, ROM, flash memory? What do you mean by flash memory?
RAM.
Yes, the answer is correct. RAM. Flash memory means your pen drive. So that is also not a volatile memory. So here the volatile memory is RAM, random access memory. Correct answer. Then, what is the purpose of a backup device in a computer system? Why we use a backup devices? To execute instruction, to store data permanently, or to provide a copy of a data for recovery purpose, or to manage input output operations. Yes,
To provide copy of data for recovery.
exactly, to provide a copy, because see, this is also right only. We use backup devices to store the data permanently, but we don't use a backup device just to store the data permanently, because it should give me a copy of data if it is accidentally or deleted, or someone has deleted, someone has hacked. So in that case, I should be able to respond, I should be able to take the copy of it. You should be able to recover it. Okay. Yes, correct answer. Now, which of the following is an example of an input device? Monitor, keyboard, printer, speaker.
Keyboard.
Yes. What are the other examples for the input device other than keyboard? Keyboard, mouse, scanner, joystick. These all are the other examples of input device. Keyboard is right. What does the term booting refer to in the computer system? Yes, everyone. Booting means what? Installing software, starting the computer and loading the OS, shutting down, or updating the system software.
Starting the computer and loading the operating system.
Correct, exactly. So it is booting process means it's loading your computer operating system into the main memory. Correct, starting the computer. Sorry. Huh. Which of the following is an example of system software here? It's a operating system. Why? Because BIOS is also part of our operating system, whereas Microsoft Word, Chrome, Adobe Photoshop, any antivirus software, any graphic software are something additional, which are nowhere mandatory or compulsory required for your computer to perform, right? So here the answer is operating system. Now instead of operating system, if the option was like this, like a firmware, if the option is there like this, let's say a BIOS, that is also right. What is the primary function of a application software? To manage hardware resource, to perform specific tasks for user, to control the flow of instruction, or to provide a backup of a data.
To perform specific tasks for users.
Correct. So here, because Word does something different than what a Chrome does, Chrome does is something different than what a Paint does. So definitely to perform a specific task, we need a application software. Hmm. Which of the following is a characteristic of ROM, that is read only memory? It is volatile, it can be written on multiple times, it stores data permanently, it loses the data when the computer is turned off. Now here the answer for read only means here something is written already which you can only read as many as times you want, but you cannot write it again. Means what? Now ROM is something given or built on your computer when it was manufacturing. When a ROM battery, a CMOS battery, when it was manufacturing, there are something written at that time only, which you and me cannot change it. It is there as permanent. So here the answer is what? It stores data permanently. Okay. ROM is something which comes in the primary memory only, but it stores the data permanently, not like RAM. Now, what is the role of a control unit in the system? In the CPU? To manage, to perform arithmetic operation, to store data, to manage the execution of an instruction, to provide backup for data. To manage the execution of instruction, because here control unit is something controlling every other unit which is connected directly or indirectly to the motherboard or to the CPU. So that's why it needs that thing to manage the instruction properly, right? So we use the control unit to manage it or to control it all the other units. Then which of the following is an example of an output device?
Monitor.
Exactly. We have a monitor. Along with monitor, speaker is also output device, printer is also output device. Correct. What is a to store data permanently, to provide faster access to frequently used data, to manage input output operation, to execute the instructions? Cache memory.
To provide.
Exactly. Correct. To provide faster access to frequently used data. So for that reason, we use the cache memory. Which of the following is a characteristic of a secondary storage device? Secondary storage means it's a permanent device, right? Permanent storage device. They are volatile, they store data temporarily, they provide permanent data storage, they are faster than primary memory. Which characteristics is true when we say a secondary storage device? Secondary storage device means it's a hard disk. So we use hard disk or we use any secondary storage device for the permanent data storage. They are not volatile. They are not used for temporary data storage because we use it for the permanent purpose, and they are quite bit slower than the primary memory, right? So the answer for this is they provide permanent data storage. What is the function of a router in a computer network?
To connect multiple networks and direct data traffic.
Exactly. Because router is a device which we don't use it for storing, backup, executing instruction. We're using it whenever we want to connect a multiple different networks. Which protocol is primarily used for transferring files over the internet? Is anyone? Files? It's the FTP, because whenever we say a file, it is file transfer protocol. Suppose if the question is here to access a web page, then the answer would be HTTP. Suppose if the question is sending an email, the answer would be SMTP. Suppose if it's converting name to IP address and IP address to name, it is DNS, domain name system, right? So here the answer is transferring files. The answer is FTP, file transfer protocol. Okay. Then we have what is the primary function of a motherboard in a computer. Now, why do we use a motherboard?
To connect and allow communication between all components.
Exactly. We are computer requires, it's in a mandatory circuitry board which we require in a computer, which is also called as in a main board, system board, right? How a mother is important for a family, the same way motherboard is also important for a computer, which is connecting and allowing all communication between all the other units and components. Yes. Which type of a memory is used to store the BIOS setting in a computer?
ROM.
Exactly. So first of all, BIOS. BIOS is here basic input output system. Now BIOS settings means like when you start your computer, your hard disk will detect the operating system and get started loading into the main memory. Then only we will get that login screen where we use a username and password and we log in and we start. So the same way here, these settings are something already there in your computer. Okay, one more example I'll give for BIOS. Now let's say the time is 12 o'clock. Now tomorrow when you start the computer, now let's say 12 o'clock you shut down. Tomorrow at 10 o'clock, if you start your computer, what will be the time? Is it 12 o'clock or it will be 10 o'clock? It is 10 o'clock. Okay, so when you turn off your computer, who is giving a battery to your system date and time? It is the CMOS battery. It is the BIOS settings, which are permanently saved in ROM, read only memory. Okay, now what is the function of a power supply unit, which is also called as PSU in a computer?
Option B.
Exactly. To convert electrical power into usable forms for the computer, because whatever the electrical supply we provide for a computer, again our computer doesn't understand that, because it is all analog signals which a computer doesn't understand. These analog signals should be converted into digital pulses. Now who does that? Power supply unit does that, which is also called as SMPS, switch mode power supply. Now SMPS or power supply unit convert this electrical power into digital pulses. Then the computer supply this power to every device, means for your motherboard, for your monitor, for your keyboard, mouse, for every device a power is required, which will be given by this PSU unit. Yes. Which type of a software is used to manage hardware resources and provide services for application software? It is system software. System software in which the operating system is also involved, which is used to manage hardware resources, means hardware devices, and providing services, plus providing all the application softwares which are required. So the here our answer is again the system software. What is the purpose of a virtual memory in a computer? Virtual memory. Virtual memory is, first of all, it's not existed in any device like RAM. We have a RAM slot. Hard disk. We have a hard disk drive available. But if you ask me what is a memory, virtual memory device? No, there is no device which comes as in a virtual memory. So what is this virtual memory? Now suppose the RAM capacity of my computer is 4 GB. But whatever the task I am performing every day, the 4 GB RAM is not sufficient for me, or my computer is performing quite slow. So I cannot afford to take one more 4 GB RAM to speed up the computer processing. But I want to speed up the processing. So in such situation, the virtual memory will help. Virtual memory means what it will do? It will take the hard disk space. Okay, let's say you have a 500 GB hard disk drive. From that 500 GB hard disk drive only, it takes some space. How much? Let's say 2 GB you allocate. That 2 GB hard disk space, it will work like a RAM for me. So that memory is something called as a virtual memory. Now why virtual memory is important? Virtual memory will help us to speed up the processing capacity of our processor. Even though we have only 4 GB RAM, now my computer is not only using 4 GB, it is using 6 GB as a RAM. Okay, so what can be the answer of this? It is to extend the available RAM using a disk space. Now disk space means here hard disk space. Okay, so these are the some sample MCQ questions which I have given you on whatever the syllabus we have covered on computer basics for your CET exam. There are 15 questions from this computer basics which will be coming to your exams. Okay, these are some reference links. E-Shiksha, if you are registered for that E-Shiksha site, then I think there can be n number of questions which you can get there on that website if you are registered, and you can solve many of the question paper. But other than that, these are also some reference links which you can use it to solve the questions, means the MCQs related to the computer basics, right? So here we are ending this sessions. So thank you everyone, and all the best for your CET exam.
Thank you, ma'am.
Voxer, may I have finished the session. Are you available? Just 1 minute, everyone. Who is the one who were giving answers to me for the MCQs? May I know the name?
तुम्ही ज्या व्यक्तीला